Hello, let us start with the tutorial number 8, that is on design of FIR filter.
Let us begin with the first problem of tutorial number 8 on FIR filter design. In the problem, they have asked us to design an LPF low pass filter given HD of e to the power j omega is equal to e to the power minus 3j omega. Omega varies from minus 3 pi by 4 to plus 3 by 4, 0 otherwise. This is the desired frequency response expected from the low pass filter. So we have a low pass filter whose now, if you look at here, the magnitude is 1. Varies from minus 3 pi by 4 to plus 3 pi by 4. The given value of n equal to 7, which we have taken it as m. Therefore, your n value will vary from 0 to 6. Let us try to find the coefficient. HD of n 1 over 2 pi. It is omega 1 to omega 2. HD of e to the power j omega, e to the power j omega n d omega. In this problem, HD of e to the power j omega is e to the power minus 3j omega, e to the power j omega n d omega. Limits of the integration is minus 3 pi by 4 to plus 3 pi by 4. So this is equal to 1 over 2 pi minus 3 pi by 4 to plus 3 pi by 4 e to the power j omega n minus 3 d omega. When I integrate this, I get this as 1 over 2 pi e to the power j omega n minus 3 divided by j times n minus 3. Varies from minus 3 pi by 4 by 3 pi by 4. Omega value will vary from minus 3 pi by 4 to plus 3 pi by 4. So we get this as 1 over pi n minus 3 e to the power j 3 pi by 4 n minus 3 minus e to the power minus j 3 pi by 4 n minus 3 divided by 2j. Further, we can simplify this as 1 over pi n minus 3 sine 3 pi by 4 n minus 3. This equation is valid for all values of n except n value is equal to 3. So we need to find for 3. So HD of 3 is 1 over 2 pi minus 3 pi by 4 to plus 3 pi by 4 e to the power j omega. N value is 3 here. So 3 minus 3 d omega. So we have 1 by 2 pi minus 3 pi by 4 to plus 3 pi by 4 1 d omega, which gives us omega divided by 2 pi varying from minus 3 pi by 4 to plus 3 pi by 4, which gives us the value 0.75. So HD of 3 is 0.75. Knowing the values of n, HD of n, W of n, we can find H of n. So n is given, HD of n we have already derived. It is sine 3 pi by 4 n minus 3 divided by pi into n minus 3 for all values of n except n value is equal to 3. When n value is 3, it is 0.75, and W of n in this case it will be 1 because we are using the rectangular window. For rectangular window, W of n will remain 1 for all values of n varying between 0 to 6. So H of n is equal to HD of n W of n. So n value varies from 0, 1, 2, 3. And HD of n, when you put the value of n equal to 0 in the equation, you get this as 0.075. So you get this as 0.075. When n value is 1, it is 0.159. W of n remains 1. So minus 0.159. Next one is 0.225. W of n is 1. So we get this as 0.225. It is HD of 3 we have calculated 0.75. So when you multiply with 1, you get at 0.75. Since the filter, FIR filter is linear phase, what we get here is HD of 2 is equal to, or H of 2 is equal to H of 4. H of 1 is equal to H of 5. And H of 0 is equal to H of 6. Using these values, we can find the magnitude of the frequency response HR of omega. It is given as H of m minus 1 by 2 plus 2 times n value varying from 0 to m minus 3 by 2. Since it is n equal to m equal to 7 odd, cos H of n cos of omega m minus 1 minus 2n by 2. So n is 7. So we get this as H of 3 plus 2, n value varying from 0 to 2, H of n cos omega, m value is 7, so 6 minus 2n by 2, that we get it as 3 minus n. So let us substitute the values. H of 3, this is 2 times H of 0 cos 3 omega, H of 1 cos 2 omega, H of 2 cos omega. By substituting the values, H of 3 is 0.75. This is 2 into H of 0 is 0.075 cos 3 omega plus it is minus 0.159 cos 2 omega plus 0.225 cos of omega. On further simplification, we get this as 0.75 plus 0.15 cos of 3 omega minus 0.318 cos of 2 omega plus 0.225 cos of omega. So H of omega, overall frequency response, should contain even the phase. So it is e to the power minus j omega m minus 1 by 2 into HR of omega. It is e to the power minus j omega into 3. HR of omega is 0.75, 0.15 cos 3 omega minus 0.318 cos 2 omega plus 0.225, it is 0.225 into 2, so this should become 0.45. So 0.45 cos of omega. This is the answer. Let us begin with the second problem of tutorial number 8. Given HD of desired frequency response, HD of e to the power j omega is equal to 0. Omega varies from minus pi by 4 to plus pi by 4, and it is e to the power minus 2j omega for all values of omega, modulus of omega, varying between pi by 4 to pi. We need to design the filter, and the magnitude characteristic of this filter is as shown here. It is 1. It's the magnitude characteristic HD of e to the power j omega. It varies from pi by 4 to pi. It's minus pi by 4 to minus pi. And it is a high pass filter, HPF. It is a high pass filter, and we need to design the filter using Hanning window. And they have given one more information, that n value varies from 0 to 4, because n equal to 5. There are 5 samples. So therefore n value will vary from 0 to 4. We need to find the coefficients HD of n, and it can be found by using the formula HD of n is equal to 1 over 2 pi integral minus pi to minus pi by 4 e to the power minus 2j omega e to the power j omega n d omega plus pi by 4 to pi e to the power minus 2j omega e to the power j omega n d omega. When you integrate this, you are going to get this as minus pi to minus pi by 4 e to the power j omega n minus 2 d omega plus pi by 4 to pi e to the power j omega n minus 2 d omega. Let us integrate this. We get this as e to the power j omega n minus 2 divided by j times n minus 2 plus e to the power j omega n minus 2 divided by j times n minus 2. And the values of omega varying from minus pi to minus pi by 4, and here it varies from pi by 4 to pi. So when you substitute the values, you get this as pi n minus 2 is taken out. We have e to the power minus j pi by 4 n minus 2 minus e to the power minus j pi n minus 2 divided by 2j plus e to the power j pi n minus 2 minus e to the power j pi by 4 n minus 2 divided by 2j. On simplifying this, we are going to get this as 1 by pi n minus 2 sine of pi n minus 2 minus sine pi by 4 n minus 2 for all values of n except n is equal to 2. So it is valid for all the values of n except n equal to 2. So we need to find for hd of n, and this hd of n is 1 over 2 pi integral minus pi to minus pi by 4 d omega plus pi by 4 to pi d omega. So we get this as 1 over 2 pi omega. It varies from minus pi to minus pi by 4 plus omega pi by 4 to pi. So 1 over 2 pi. So minus pi by 4 plus pi minus pi by 4. When we simplify this, we get 1 over 2 pi. It is 2 pi minus pi by 2. So we get this as 0.75. Using these two, we have to form a table, and it is given is Hamming window, and the expression for Hamming window is given by W of n is equal to 0.5 minus 0.5 cosine 2 pi n divided by m minus 1. Here the m value is 5. So I can rewrite this as 0.5 minus 0.5 cos of 2 pi n by 4. So further simplification gives me 0.5 minus 0.5 cos of pi by 2 n. So let us form the table. It is n, hd of n, w of n, this is h of n, it is hd of n multiplied by w of n. N is 0, 1, 2, 3, 4. So So HD of n values are minus 0.1591, minus 0.225, HD of 2 is 0.75, this is minus 0.225, this is minus 0.1591. W of n is 0, 0.5, 1, 0.50. So you get this as 0, minus 0.1125, 0.75, minus 0.1125, 0. Now we'll try to get the h of omega. H of omega is given by e to the power minus j omega m minus 1 divided by 2 multiplied by, since it is m value is odd, so we can write hr of omega as hm minus 1 by 2 plus n value varying from 0 to m minus 3 by 2 h of n cos omega m minus 1 minus 2n divided by 2. This gives me e to the power minus j omega 4 divided by 2, so it is 2j omega. Hm minus 1 by 2 is 0.75 plus it is h of 0 plus cos omega, here n is 0, so it is cos of omega, here 5 minus 1, so you get this as 4 divided by 2, so cos 2 omega, and it is h of 1 because it is n value is 1, so 5 minus 1, 4 minus 2, so you get this as cos of omega. So this you get, further you can simplify this, e to the power minus j omega 2, 0.75, h of 0 is 0 and h of 1 is minus 0.1125, here there is 2, so you get this as 2 times, so 1125 into 2 cos of omega. So you get this further, you can reduce this e to the power minus j omega 2, 0.75 minus 0.225 cos of omega. This is the answer you should get. Let us begin with third problem of tutorial number 8. Given the magnitude hd of e to the power j omega is equal to 1 for all values of modulus of omega varying between pi by 4 to 3 pi by 4 and it is 0 otherwise. So here the magnitude is given. So let us multiply the magnitude with the phase value in order to get hd of e to the power j omega. Here the given value is n equal to m equal to 11. So therefore we should have hd of e to the power j omega e to the power minus j omega m minus 1 by 2. That will give us, this is 1, e to the power minus j omega, m is 11, 11 minus 1 by 2, that is 5. for all values of omega between pi by 4 to 3 pi by 4, and it is 0 otherwise. So note the difference. Earlier, if you look at earlier, we had the HD of e to the power j omega given, but this time they have given the magnitude, so we need to convert it into desired frequency response by multiplying with the phase factor. With this information, they have given one more information, that is, we have to make use of Bartlett window. Bartlett window needs to be used, and the n value will vary from 0 to 10. Now we'll try to plot this. It is pi by 4 to 3 pi by 4, the desired magnitude of frequency response magnitude. It's 1, and it is minus 3 pi by 4 to minus pi by 4. Looking at this, we can say that it is a band pass filter. We are going to design a band pass filter using Bartlett window with n value equal to 11. Let us try to find the coefficients HD of n. It is 1 over 2 pi omega 1 to omega 2 HD of e to the power j omega d omega. It is 1 over 2 pi. It varies from minus 3 pi by 4 to minus pi by 4 e to the power 5j omega. Here you have e to the power j omega n. So e to the power j omega n d omega plus, it is pi by 4 to 3 pi by 4 e to the power minus 5j omega e to the power j omega n d omega. On further simplification, we get this as 1 over 2 pi. It is minus 3 pi by 4 to minus pi by 4 e to the power j omega n minus 5 d omega plus pi by 4 to 3 pi by 4 e to the power j omega n minus 5 d omega. So 1 over 2 pi, it is e to the power j omega n minus 5 j times n minus 5 minus 3 omega value minus 3 by 4 to minus pi by 4 plus e to the power j omega n minus 5 divided by j times n minus 5. Omega value varies from plus pi by 4 to plus 3 pi by 4. So it is 1 over pi n minus 5 divided by 2j e to the power minus j pi by 4 n minus 5 minus e to the power minus j 3 pi by 4 n minus 5 plus e to the power j 3 pi by 4 n minus 5 minus e to the power j pi by 4 n minus 5. On further simplification, we get this as 1 by pi n minus 5 sine of 3 pi by 4 n minus 5 minus sine of pi by 4 n minus 5. And this is valid for all values of n except n value is equal to 5. So let us try to find HD of 5. It is 1 over 2 pi minus 3 pi by 4 to minus pi by 4 d omega plus pi by 4 to 3 pi by 4 d omega. So it is 1 over 2 pi, it is minus pi by 4 plus 3 pi by 4 plus 3 pi by 4 minus pi by 4, which will give us half, that is 0.5. They have asked us to use Bartlett window. Bartlett window is defined as W of n is equal to 1 minus 2 magnitude of n minus 5 into 2 divided by 10. So we will make use of HD of n and W of n and we will try to compute H of n. So we have n, HD of n, W of n and H of n. So n value is 0, 1, 2, 3, 4, 5. 0 is 0, 1 is also, 0 is 0, 1 is 0, 2 is 0, 3 is minus 0.3183 and 4 is 0, 5 is 0.5. Whereas W of n, Bartlett window function, it is n value 0, it is 0, n value is 1 is 0.2 and n value is 2 is 0.4. This is 0.6, 0.8 and 1. So this becomes 0, this is also 0, 0 and here you get this value as minus 0.19098 and this is 0 and this is 0.5. So this is H of 6, H of 4 is H of 6, H of 3 is H of 7, H of 2 is H of 8 and H of 1 is H of 9 and H of 0 is H of 10. So using these H of n values, we have H of omega, that is a frequency response, and you know that here n value is 11 odd, so this is given by H of m minus 1 by 2 plus 2 times summation n value varying from 0 to m minus 3 by 2 cos of omega m minus 1 minus 2n by 2 multiplied by h of n. In this case, it is h of 5 plus 2 times n value varying from 11 minus 3 by 2, that is 4, cos of omega, it is 10 minus 2n. So you get this as 5 minus n h of n. So here we have h of 5 is 0.5 and the value, only one value we have, that is h of 3. So we get this as 0.5 minus 0.38198 cos of 2 omega. This is the magnitude we have. So we'll find out h of omega. H of omega is e to the power minus j omega m minus 1 by 2 hr of omega. It is h e to the power minus j omega 5 and multiplied by 0.5 minus 0.38198 cos of 2 omega. This is your answer.